So we've talked about quadratic equations, we've talked about quadratic functions, then we have basically quadratic applications coming at the end of what we do in chapter 2 of our text. So the applications sort of end up clinging to the same broad topics we saw in chapter 1. We've got cost, revenue, profit type stuff, and then we've got an economic application with supply and demand equations. So digging into the first example in the notes, we're given a revenue function and a cost function. So our R of x in this instance is 110x. The cost function is now no longer linear. You'll notice it's got a it's got a quadratic piece to it. So we have 600 plus 40x plus x squared. So the same idea in terms of how to calculate profit still applies, right? Profit is still revenue minus cost. So we do that. We'll have 110x minus, again, remember the parentheses because every one of these terms ends up picking up a minus. So we have 600 plus 40x plus x squared. And I'm going to rearrange this, so I'm going to give you a pause if you need to work out the algebra that ends up ensuing here. When it's all said and done, what you should end up having is the following. Negative x squared plus 70x minus 600. All right, so there's my profit function in this case. All right, so if we want to know where we break even, we've said before, you could technically do revenue equals cost, or you can say profit needs to equal 0. So at break even, so at the break even point, we know that has to happen. Our profit function value has to equal 0. Now from here, you could apply either of the two techniques we saw in section 2.1 to work out, the possible values. I'm just going to use the quadratic formula here. We'll see some factoring later, but in this instance, so A is -1, my B is 70, my C is -600. So now I can feed those guys into the quadratic formula. So we'll have negative B based on our formula. Again, you can go back and look. You don't have to commit it to memory. I'm just about to write B right there. So negative 70. That's one of the worst 70s I've ever written. I'm going to try not to cheat and turn a B into a 70. So plus or minus 70 squared minus 4 times my A of -1 times my C of -600. And you can check this sum, as it turns out, this discriminant does work out to be positive, so we're actually going to have two different solutions. There are two different production levels that could, hit our break-even point. So divided by 2 times -1. All right, so now if I work out the arithmetic here, so still got the -70, plus or minus. What ends up underneath this radical is 70 squared is 4,900. All this stuff here, we've got 3 negatives, so we have 4,900 minus 2,400. That's convenient because, as it turns out, 2,500 is actually a perfect square, so we get nice clean integers. It's almost like I planned that, right? So when you work this out, -70 plus or minus 50 over -2. So we have two solutions. We work this out with the plus 50 and then again with the minus 50. So if you do the plus 50, you get negative, so you have -20 over 2. That's 10. For minus 50, you get a -120 over 2. That gives you -120 over -2, rather. Yeah, the minus is important here. So we get -10, -6, 10 and 60 as our production levels. Part B basically says, well, what if we can't make more than 50 of whatever it is? Where should we set production? So if production is capped at 50, sorry, we can't make 60 of whatever it is. So to break even, we need 10. Now, generally speaking, as a business, you don't just want to break even. You probably want to maximize your profits. We'll talk more about maximum profit and maximum revenue and things like that in another example. But for now, let's just go ahead and transition to the next guy up. Oh, by the way, there isn't, as you said, there's a note in the example that says sketch your cost and revenue functions on the same set of axes. We've seen enough of Desmos at this point that hopefully you'd be comfortable with going in and generating that yourself, or you could pop it into your graphing calculator. Excel's also pretty good at generating those. You just have to, play around a bit to make sure you get the two functions on the same axes, but it can be done. All right. So the next example continues to deal with like a cost, revenue, profit thing, but now we're looking at a monopoly market where only one supplier basically exists. There, competition has been squashed out till there could be only one. So in that instance, it turns out the revenue ends up getting constrained by the demand function for whatever's going on in this particular market. So in a monopoly market, you've got the thing listed here, or not P of X. It's not just revenue is straight profit. That monopolies have their advantages. If you're the one who holds it. But yeah, it's not just revenue just straight up turns into profit. Costs don't vanish. Anyway, so we're given, this is what goes on in a monopoly market. So in the next example here, we're told we're dealing with a monopoly for, a headphone manufacturer. I have no idea how one headphone manufacturer squashed out all the others, but let's just run with it. So we have a cost function that's supplied. You can read that guy off there. I'll be writing it up momentarily. We're given the demand function, which is important. So in this instance, we're given what the demand function looks like in terms of x, not q, but we have a demand function of 500 minus 2x. So then our revenue function, we just feed that guy in, 500 minus 2x times another x. So we have 500x minus 2x squared. So that's our revenue as a function of x. And our cost was given to us as 3,600 plus 100x plus another 2x squared. All right, so now, profit, same thing, revenue minus costs. So we have 500 minus 2x squared minus that sucker, 3,600 plus, that should be 500x, by the way. Sorry, I left out the x as I was writing this. It should be, that's the r of x. Don't just assume I dropped the x. That was just a typo. Plus 100x plus 2x squared. So we get that guy worked out. When we pound out all of the algebra, my profit function, again, I like arranging it. The examples in the notes leave the x squared terms in the back. I find it easier if you kind of put them toward the front. So we have negative 4x squared plus 400x minus 3,600. Okay, so to find break even, which is what we're asked for initially, we want to find the break-even point. We're also asked to find max profit and where it happens. So I'm actually going to do the factorization trick here because, as it turns out, if we divide this whole equation by -4, both sides, this ends up giving me x squared minus 100x. As it turns out, when you divide that thing by 4, you get plus 900 equals 0. And you might be saying, well, why not use the quadratic formula? You can, and you will get to the exact same place. That's the neat bit. It just happens that the factorization ends up rather clean here because we need two numbers that multiply together to give us 900, but that add up to give us -100. 900 actually has a lot of factors, but oddly enough, you may notice 90 times 10 is 100. And if we slap a minus in front of each of them and add it up, we'd get -100. So we have x minus 90, x minus 10. And so then our break-even points happen at these two spots, either x equals 10 or x equals 90. So we break even at either x equals 10 or x equals 90. That's where, that's where our profit is 0. We've perfectly balanced our cost and our revenues. So again, that's not generally where we want to be, but it is important to know from a business standpoint. All right, the next thing is let's work out our maximum profit. So our profit function hasn't changed at all here. We're still working with this bad boy as our profit function, the negative 4x squared deal. So to find max profit, since this is a quadratic function, like we said in the last section, finding a max or a min is an exercise in tracking down the vertex. So to find that max profit, we're just going to nail down where the vertex is. Remember our formula from last time was negative b over 2a. So our b is this 400. So we have negative 400. Down below, we're going to have 2 times a, which in this instance is, negative 4. So we have 2 times negative 4. Work out the arithmetic here. 2 times negative 4 is negative 8. Negative 400 divided by negative 8 is, in fact, 50. So in order to maximize our profits, we need to make 50, as you said, we need to make and sell 50 sets of these headphones. Again, I don't know if we are guaranteed we can pull that off, but hey. So then the max profit, we just take this p value or this x value of 50 and plug it back into this guy. So again, everywhere we see an x, 50 goes into its place. So we'd have negative 4 times 50 squared plus 400 times 50 minus 3,600. When you work out all of the arithmetic there, you should end up getting a maximum profit point of $6,400. So again, this is like on like a weekly scale or something like that. Again, the numbers seem sort of low, but it makes the arithmetic easy to work out. So we've seen how to find break-even points. We've seen how to track down maximum profit using, these quadratic functions to describe stuff. So there's one more of these examples that we'll see in the next video, but we're going to take a bit of a detour and come back to that on supply and demand stuff. So, stay tuned for the next video.